Hi, this is Julian. I'm the CTO and co-founder of DataKin. Today I'm going to talk about data lineage and observability with OpenLineage. So for this presentation today, the agenda is as follows. I'll start with giving a little bit of context, talking about the need for metadata. And then I'll go over OpenLineage, which is an open standard for lineage collection, and Marquez, its reference implementation. And I'll end the presentation with talking about Spark observability with OpenLineage in particular as an example of application. So first, let's talk about the need for metadata. And so I think in an organization, you often have multiple teams consuming and producing data and depending on each other. And within the team, people are fairly aware on how things work, how they depend on each other, how things change, and things work fine. But as soon as you go across teams, there's a lot of friction. And there's a lot of problems that come from changes happening and people not being aware of it, not really understanding the context of changes, and that creates a lot of friction. And these come from a limited context around data, right? Often you consume data or you produce data, but when you consume, you don't know where it's coming from. You don't know what its schema is supposed to be. You may not know who the owner is. You don't know how often it's updated and where it's coming from. And when you produce it, data, you don't necessarily know who's using it. And it's kind of basically hard to go beyond everybody who's consuming several times and sometimes multiple hops downstream from you, or where the data is coming from multiple hops upstream from beyond the data set. So there's kind of very limited context, and it is hard. I mean, you can get to this information, but it's just hard and time consuming to get to it. And this part of getting value out of the data, we talk about a lot of the work of data scientists or data engineers is cleaning up data, like fixing things, making sure things work. And that kind of takes a lot of work. And I built this, I'm inspired from the Maslow's hierarchy of needs, which is, the Maslow's hierarchy of needs is about before you reach happiness, you need first to have food, you need to have shelter. And then once you have that, you need to have safety. And once you build on those basic things, on top of the pyramid, that's how you can, reach happiness and in your life. And there's a similar hierarchy of needs for data in that, like, first, before you can get value out of your data, it needs to be available, and you need to have it in a location or in a tool that you can start analyzing it. And second, once the data is available, you need to make sure it's fresh and it gets updated on time, right? So this data freshness notion. And third, once the data is available and it gets updated on time, it needs also to be correct. And once you build on this foundation, then that's when you can start trust your data, build trust in your data, and work on how do we optimize our business, right? Or how do we find new business opportunity? But that the actual getting value of your data. But first you need to get all those three things out of the way so that you get, your head above the waterline, which is kind of the illustration here. And that's how we launched OpenLineage last year. And the goal was really to enable getting this context, understand what's happening, how things are changing, and really get to the bottom of those problems. And so we were honored to reach out to a group of great creators and contributors from major open source projects, and really reach out to this group and get this project started last year, and really defining a standard for lineage and metadata. And the purpose of OpenLineage is to define an open standard for metadata and lineage collection by instrumenting data pipeline that they're running. And, so that's kind of our mission statement here. And to go simpler, really the purpose is to be the exit for data pipeline. So, today when you take a picture with your digital camera or smartphone, it's going to encode in the picture itself the coordinates of where it was taken, when it was taken, and so on, right? And so OpenLineage is really this purpose for data pipelines. The best time to capture metadata is when the job is running. That's when you know what was the version of the code, what was the schema of the input, what was the schema of the output, how long it took to produce it, and really being able to encode and capture this metadata at runtime. And so before OpenLineage, there are a bunch of projects that are interested in collecting data lineage. Things like Amundsen, Data Hub, Marquez, Atlas, and others are all projects that are interested in visualizing lineage and understand lineage across the data ecosystem. And they're all figuring out how to extract this lineage and from the various tools we're using to process data. And so there's lots of duplication of effort. Each project has to instrument all of those projects. And it's also very brittle because those external integration break whenever each of those projects changes. So with OpenLineage, we really reach out to all those people in this ecosystem, and we sat together and say, like, okay, let's define a standard way to represent lineage and metadata around it so that we can simplify this problem. And so there are multiple advantages. One, the effort of integration is shared. So instead of reinventing the same concept over and over, we can have a standardized generic representation of lineage. And second, because OpenLineage is a spec and it's like an interface, and it's just really a client, an interface, and a definition of lineage, you can actually push it in the ecosystem. Like instead of integrating from the outside and extracting lineage from Spark, SQL, your schedulers, you can actually make all of those things, expose the lineage they understand internally into a standard representation. So it's a lot more robust from an evolution of the ecosystem perspective, and it's a lot more efficient from a duplication of effort perspective. And so to clarify what is scope and not in scope, and really OpenLineage, there's a clear parallel between OpenLineage and OpenTelemetry. OpenTelemetry is really capturing traces and metrics for services, and OpenLineage is about capturing similar notion of data lineage and the connected metadata from the data pipelines. And so it's really a spec and the integrations on how we expose that spec. And then there's a configurable backend. So those events that capture lineage can be sent to various backends and can be consumed by various consumers. So OpenLineage is really the client side specification of these lineage events. And on the backend side, you can have Marquez, obviously is your reference implementation. You can consume those events in Data Hub, in Amundsen, in Atlas. And so that's kind of not the scope of OpenLineage. This is a whole like how we index and collect this information and use it for various use cases. The core model of OpenLineage is defined as a JSON schema spec. So there's a schema that defines how you represent a run of a job and what inputs and outputs it has. So this is based on consistent naming of recurring jobs and their input and output data sets. So that's the core model of lineage. There's a run of a job, it starts at a given time, it ends at a given time, and it's read from these data sets and wrote to those data sets. And now around this core model, you can attach the notion of facet, which each facet is this atomic piece of metadata that describes one aspect of that entity, right? For a job, that could be what was the version of the code of this job, like for example, a Git shell. For a data set, that could be what was the schema of this data set at that time. For a run, it could be what was the query profile of the job that just finished. And so you can capture various pieces of metadata like this, and they're all self-contained little specs that makes it really easy to extend and customize OpenLineage. And so, like I said, once you define those events, the protocol is flexible. So it's meant to be the only constraint is that we can send asynchronous events, like which are observations about the running jobs. And so a unique run ID identifies a run and enables correlating those events that are describing, making observation about a particular run. And that can be sent to configurable backend. So typically, in the case of the Marquez integration, it's an HTTP backend where you can send just post events. But that could be Kafka, that could be anything that accepts sending JSON formatted events. And so some of the example, you would start with the run start event that would contain what was the source code version, what were the parameter passed to this particular run. And then you would have a run complete event that would say, hey, those were the data sets we read from. That was the schema they had at the time we read from. Those are the data sets we are writing to, in what version, and what was their schema when we were done writing. And so this notion of facet is really this extensible notion. So like I was saying, those facets are atomic pieces of metadata. They're identified by a unique name, and they can be attached to core entities. So the advantage of this approach is, instead of having a monolithic spec that would take a long time to converge on, we were able to converge very quickly on the core spec of what is lineage, right? You have this notion of jobs and inputs and output data set. And then each of those aspects of metadata can be discussed independently, right? And it's really important to be able to decouple things that are controversial from things that are fairly easy to agree on, so that we can move faster, right? And we can make all those, and also have different set of people, whoever is interested in different concepts, can help drive this effort, right? It could be driving the effort about column level lineage, could be driving the effort about data quality metrics, driving the effort about schema or query profiles for performance. So those are kind of individual things that we can define independently and have quick independent discussion and agreement on standardizing those. And it's also decentralized. So you have those core central facet part of the spec, but you can also have your own custom facet that makes it easy to experiment and add your own notion of facet, right? If you have like a proprietary system, you can add your own custom facet that are defined by you and controlled by you, and attach them in the metadata. And so that's an easy way to experiment and decentralize and enable using OpenLineage without necessarily going through an approval mechanism for everything. And so to give you examples of data sets, of facets, at the dataset level, for example, you can have statistics for data quality. You could have the schema information. What was the version of the dataset if you're using a version storage layer like Delta Lake or Iceberg? It could be the column level lineage if the transformation you're having exposes the information. At the job level, it could be where's the source code for this current version of the job, what were the dependencies of the versions, what parameters were passed, or hyperparameters if it's a training job. What was the query plan for this particular job, and if it's self-contained like a SQL query, it could contain the SQL query itself. At the run level, you would have the schedule time, when did it start, when did it end, what was it scheduled for, what the batch ID, if this is relevant, what was the query profile. And so I discussed as OpenLineage as the spec for collecting metadata and how to instrument various things. And Marquez is a reference implementation that helped store and version everything collected in OpenLineage. So really, in this context, the way Marquez was built is the goal was to collect all the lineage informations from a data ecosystem, right? And get visibility in the dependencies of everything and version everything that's happening. So this is kind of an illustration of what a data platform could look like. And in this example, you have ingestion, typically you have a storage layer for streaming and batch with things like data in motion. In Kafka, for example, storage could be a cloud distributed storage with some abstraction on top like Iceberg or Delta Lake. The compute layer may have streaming like Flink of Kafka streams or other things. And on the compute layer, typically you have a scheduler like Airflow or something else that may schedule Spark jobs or SQL queries in Snowflake, for example. And you have a BI layer on top. So the goal is to instrument all those things. And this is really just one example of things as an illustration, and keep track of all this lineage and metadata in one place. And the difference between the OpenLineage model and the Marquez model is OpenLineage is making an observation about a running job, right? There's a run of a job, and it started at this point, finished at this point, and right from this row to this. Now, what Marquez is doing is taking all those observations and keeping track of all the changes, right? It will keep track of whether the dataset schema has changed. It will keep track of whether the job definition has changed. Now that we change the version of the code, or like the inputs and outputs have changed, and keeping track of all the change. So it's taking those events and versioning the metadata as it's changing, so that you can keep track of the changes and understand how the data evolves over time. And so to give an example of what Marquez is doing, and kind of situate Datakin, which is my company, on top of this, you can look at OpenLineage and Marquez standardized metadata collection, the job runs, what parameters were passed, what was the versions, what were the inputs and outputs, and really all that metadata that's collected. And Datakin is just leveraging this data and for understanding operational dependencies, doing impact analysis, troubleshooting, what has changed since the last time this thing worked. And so it's really leveraging the exact same metadata collected with OpenLineage and Marquez to build a better lineage analysis and better understanding and quicker troubleshooting on when something goes wrong. And now I will talk more specifically about how we do the Spark integration for OpenLineage, right? And the goal is how do we achieve observability for Spark in this particular context? And OpenLineage has support today for schedulers like Airflow, for warehouses like BigQuery and Snowflake, or even Postgres databases, and Spark. And there's more integration on the way that are in progress and that people are adding. And so, and in the context of this presentation, I'll dive in the Spark integration. So first, the way you set up the Spark integration is you just add the extra Java options to your Spark job. So it's meant to be configured orthogonally, right? You could configure it once for all your Spark jobs and start getting visibility in what's happening. And you pass it information of your OpenLineage endpoint that's going to consume the OpenLineage events. And then it's going to start collect metadata. So whenever, the way this works is it adds a listener to the Spark context. And so it's going to be able to see the logical plan for each of your Spark runs. And so it's going to collect from that, is connecting the inputs and outputs of the jobs, and collect the where it's reading from, where it's writing to. It's also from the profile, it's going to collect the row count and byte size, how many rows were consumed from the input, how many rows were produced in the output. And it's also collecting the logical plan in a standard way. So all very useful information if you want to build observability and understand what happened and how things change over time, right? Like typical use case of understanding if, is the row count consistent with what it has been historically. And so when we model a lineage for Spark, there are multiple levels of nesting, right? So if we take the example of running a Spark job within an Airflow DAG, you would, like a very typical use case, is to model that as an Airflow DAG workflow that will have 3 steps in a simple case. You may start a Spark cluster initially, then you will run your Spark job, and then take down your Spark cluster. So in the OpenLineage model, the task that starts a cluster is a task, it's a job that exists. It doesn't have any input and output data set. And then the Spark job is it's in Airflow, it's itself an entity. And then it runs the actual Spark job, which will actually have multiple running steps, right? Each action in your Spark job will actually be a different run, right? So we model each individual action inside the Spark job as its own run with inputs and outputs. And that's what constitutes the lineage. And so as part of this model, you'll be able to see, the nesting of there's a Spark job that's made of multiple actions, and here's the status of each of those actions, and whether it was successful or not, and what data set it consumed or produced. And so to give you an example of what that looks like, once you have the model and you have multiple jobs reading and writing from data set, you can start visualizing how they depend on each other, right? And understand how those jobs depend on each other in a more wider lineage view of in Marquez. So in Marquez, for example, you have a lineage API that lets you retrieve, show me all the subgraph that's connected to a particular node. And that lets you visualize your lineage graph and see the dependencies. Another use case, now I mentioned that OpenLineage integration in Spark will collect input size and output size. So that lets you see over time how this change, right? When you look at a data set in Marquez, for example, you'll see the history of the version of the data set. Every time it was updated, there'll be a new data set version, and you'll see the facet that are attached to it. So there's going to be a statistics facet that captures the row count and the byte count returned to it for each of those runs. So you can start keeping track of how the size of the data set evolved over time. And if, for example, if there's anything suspicious in having suddenly a drop in row count, for example, which is kind of the coarse grain, the coarsest grain data quality metric. And there's also effort going on adding more quality metrics from things like Great Expectations and DQ, and enable enriching this information if you want to keep track of metrics at the column level. And on that, I'll encourage you to join the conversation. So you can find OpenLineage on GitHub. There's an OpenLineage repo. We have a Slack channel. You'll find all the contact information on the OpenLineage GitHub repo. So there's Slack channel, Twitter account, and Google groups for people who prefer email. And similarly for Marquez, you can go on the Marquez GitHub to find all the information and how to join the Slack channel and join the conversation. And it's really, and that's where you can, if you have questions on how to use Marquez or what the appropriate way of what the roadmap for adding more integration to OpenLineage, this is where you would find this information. And on that, I am going to thank you and encourage you to ask questions. And thank you very much for listening.